Today, the farmers face a major challenge. They depend on their soil, but they cannot see what is happening inside the soil. They don't know the exact moisture, temperature, NPK, nutrients, pH, and conductivity what their soil needs. Because of this, farmers often overwater or underwater crops, use excess fertilizers, lose crop yield, and waste water, money, and time. In simple words, farmers are guessing, not knowing what their soil needs. For example, Rajat is a poor but extremely hardworking farmer. Every day before sunrise, he walks through his fields hoping that this season finally be better than the last. But today something feels wrong. As he looks closely, some parts appear weak, some leaves have turned yellow, and a few crops are already drying up. Rajat becomes tense. He wipes the sweat from his forehead, wondering what went wrong this time. These changes happen slowly and invisibly, and farmers like Rajat only realize the damage when it's already too late. And that's where our innovation comes in, a complete 7-in-1 smart soil monitoring system powered by AI. Early morning, the smart soil system sends an alert on a farmer's device. The farmer instantly knows his soil needs attention. The crop shows sign of dryness. Now we will see the components used in this device. So the first one is Smart Soil Sensor. It measures moisture, nutrients, nitrogen, phosphorus, potassium, temperature, humidity, conductivity, and pH from the soil. Attaching multiple individual sensors would make the setup complex, so we choose to use a 7-in-1 soil sensor that integrates all these measurement capabilities into a single module which looks like this. Now our next component is MAX485. Since our microcontroller cannot read RS485 signals directly, so our MAX485 module converts RS485 signals to TTL signal. Our final component is ESP32, which reads the TTL signals coming from the MAX485 module, processes the sensor data, and uploads the information to the cloud. And then from the cloud, whether Firebase or Blink, the data is delivered wirelessly via Bluetooth or Wi-Fi to the mobile application for real-time soil monitoring. We have created a flowchart to clearly illustrate the entire process. The process starts with the 7-in-1 soil sensor, which measures the soil parameters required. Then the sensor sends data in the form of RS485 signals to MAX485 module, which converts it into TTL level signals so the microcontroller can read them. Then the ESP32 takes the TTL signals from the MAX485 and processes the sensor data and uses its built-in Wi-Fi to send the information to the cloud, where it is stored in database. The cloud also provides APIs that allow applications to fetch real-time and historical soil information. It can also directly forward data to the web dashboard if needed. Finally, the data is displayed on the web application dashboard. Users can monitor real-time readings, check soil health, and analyze trends from anywhere. Now this is our real working connections of our hardware part of prototype, which is connected to a 5-volt battery. Now let's take a look what the farmer sees on his device. Gaia Guardians presents Saptamruda, a complete smart soil intelligence system. Our platform does not just measure soil moisture, it provides complete multi-dimensional soil analysis, helping farmers understand everything happening around the soil in real time. On the home page, we see highlight our motto, Artificial Intelligence Backed Soil Analysis, a permanent solution to crop loss. Now first we have to log in to fully access each and every feature. So here we log in as username Ansh. Now take a quick tour of this website. So with our system, we get 3 powerful tools at our fingertips. The first one is weather reports, which records real-time climate information and temperature updates. Then soil analysis, which gives complete real-time soil health status. Then recent records, which track previous records of soil activity. This makes the website act as a digital farming assistant, giving farmers complete control of their field remotely. Now we will see what is there in soil analysis. Opening the soil analysis section, we enter the most important part of our website, the 7-in-1 soil sensor dashboard. Here farmers get real-time measurement of the 7 most critical soil and crop health parameters collected by our RS485 based 7-in-1 sensor. So the first one is temperature, which helps to understand crop stress and fungal risk. Then there is humidity, which determines the environmental conditions. Then pH value, which is essential for nutrition absorption. Then there is electrical conductivity, which shows salt concentration in soil. Then moisture level, which is essential in irrigation decision support. Then nitrogen, which is essential for growth and leaf development. Then at last, phosphorus, which is very important for root and flowering development. All these values are sent wirelessly from the field to the ESP32, then to the cloud, then to our website dashboard. Every card updates wirelessly in seconds, giving farmers actionable intelligence instead of raw numbers. The farmer sees everything in a simple visual and easy to understand layout, including icons, colors, and readings. Since now all are in green background, which means all are in good range, but if there's out of range in the values, then it will turn background color to red. This makes easy to focus on attention demanding parts. This makes it extremely easy to monitor the soil health without going to the farm physically, which saves time and effort. Now we will come back to the home page. On the home page, the farmer can check all his past soil and weather records by simply clicking on the recent history. Then, in the recent record, we will see temperature graph. The first thing he sees is the temperature graph showing the highest and lowest temperatures record over the past days. This helps the farmer to understand how heat patterns may affect crop growth and water requirements. Next, we will see the humidity graph. This is the humidity graph, which shows how much moisture is present in the air. Humidity plays a major role in irrigation planning and preventing crop diseases. Now the next is soil moisture graph. The soil moisture levels recorded by the sensor. This tells him whether the soil is dry, wet or perfectly suitable for irrigation. Then the next is soil pH graph, which helps him to understand if the soil is acidic or alkaline over the time. Balanced pH is necessary for proper nutrient absorption. Then there is electrical conductivity graph. The system also displays electrical conductivity, which indicates the nutrients and salt level in the soil by the weekdays. Then we will see phosphorus and nitrogen. Finally, the farmer views these two trends, these two essential nutrients for plant growth. By tracking these values, he can apply fertilizers only when needed. Now we will go back to our home page. As you can see at the top, we have quick menu options, news for latest agriculture updates, about section to know about a platform, and help section for user guidance. As we scroll down slowly, at last we will see these are all what we see earlier. This is FAO, this is about us, and then at the last when we see the footer, this is not just monitoring. This is AI powered soil health decision making. Our built-in AI analyzes every sensor reading, detects problems instantly, and even sends smart messages through the chat box like watering suggestions when the soil is dry. It then provides complete guidance on irrigation, fertilizer needs, and soil improvement to help farmers take the right action at the right time. Thank you.